This is a video walkthrough of using the Eadie Hofstee analysis for enzyme kinetic data. In the Eadie Hofstee analysis, the equation is rearranged by multiplying both sides by Km plus S and then rearranging. And the resultant equation that is achieved is the velocity equals Vmax minus Km times V divided by S. This has less problems with amplification of errors in the small data points, and it also behaves a little bit, but not a lot of bit better, closer to Vmax. Again, it falls down close to Vmax. When thinking about how to graph this, the velocity is a y value. The intercept is the Vmax. The slope is negative of the Km, so minus Km is the slope. And what's plotted on the x-axis is V over S. So mathematically, we need to set up the column that's V over S because we already have the velocity. What's interesting is notice that the first column that's showing up on my current spreadsheet is V, which goes on the y-axis. So if you just highlight the cells to make your graph, your axes will be flipped. So make sure you rearrange your axes to reflect how the data should be presented. To calculate V divided by S, we're going to set up an equation. So we're going to say equals velocity divided by substrate. And we're going to do that for all of the data points. Notice the ones at low values are a little messy. That is not uncommon. So how we find Vmax from this equation is, notice Vmax is the y-intercept. Here it's saying it's 0.5949. If you don't want to just read it off the equation, you can write equation to find that intercept, and the equation is intercept. And then you highlight, notice it tells you down below what to do. We're going to highlight the known y's. What goes on the y-axis is the velocity. So we're going to highlight the velocities. And what goes on the x-axis is V over S. So we're going to highlight those values and then close parentheses. Notice velocity has the same units as, Vmax has the same units as velocity. So this is going to be millimolar EMP, which is the product per minute. And notice my data has, some of these only show one. It's partially because Excel chops off lagging zeros. We're going to assume they have two, just because I can't imagine an experiment where you don't measure at least two. And you can use the little arrows to adjust it to the correct number of sig figs. Km from this plot is slope, or the negative of the slope. So we're going to say equals minus slope. And similar to the formula that we use to find intercept, when you type in a command, it tells you how to find it. It says known y's. My y-axis are the velocities. And my x-axis, or my x's, are V over S, close parentheses. Again, it shows you too many sig figs, and it should agree with what you observed when you did the line fitting on your graph. And notice those are the same values. And again, we're going to go to a more reasonable number of sig figs. And my axis is not labeled correctly here. This should be, oh no, that's correct. Why is that correct? Why is that correct? Well, my velocity has units of millimolar per minute, and this has units of millimolar. So when I divide them, you get just the per minute. If we think about what units Km should have, that millimolar comes back. And why does it come back? Well, notice it's V divided by S, right? So the slope of the line is rise over run. Rise is per minute, run. Oh, sorry, rise is millimolar PMPP per minute. My x-axis is per minute. Those per minutes can cancel each other out, and you get just the millimolar. So use your units to help you out. Let's compare these values to what we did when we did the nonlinear curve fitting. So 0.59 and 2.57. Notice we had 0.59 stays the same. The Km is slightly larger, so we observe 2.57. And notice that had very minimal effect on the curve. So if you look at that fit, it fits the data pretty well. So the Eadie Hofstee also provides a linear curve. It's really easy to read because the Km is the slope and the Vmax is the y-intercept. And it doesn't have the same kind of amplification of errors that we observe with the Lineweaver-Burk. However, it is less popular because it was developed later.